Okay, so today we're going to talk about our same ratio, sine, cosine, and tangent, but we're also going to talk about cosecant, secant, and cotangent. So if you notice, you're looking at our ratio for sine and our ratio for cosecant. They are opposite reciprocals of one another. So this one was opposite over hypotenuse, while this one is hypotenuse over opposite. Same is true about cosine and secant. These ones are reciprocals of one another, as are tangent and cotangent. So what we're saying here is, let's take sine for example, whose ratio we know is opposite over hypotenuse. So let's say we're looking at this picture over here to the left, and that we know that the opposite side measures 2, while the hypotenuse is 3. Then my ratio for sine would be 2 over 3. That means my cosecant ratio should be 3 over 2. So all these mean is that we should take the reciprocal or flip our fractions over. So on number 1, they want the 6 ratios. Well, here is theta. So sine is opposite, which opposite of theta is going to be 8 over the hypotenuse, which is 17. Cosecant is hypotenuse over opposite, so this one should be 17 over 8. Cosine is adjacent, which is 15 over hypotenuse, which is 17. So secant, its reciprocal, will be 17 over 15. For tangent, our ratio is opposite, which is 8, over adjacent, which is 15. So cotangent would be 15 over 8. So for number 2, we're going to do the same thing. I'm going to draw myself a right triangle here. And I'm going to put my theta down here at the bottom. They tell us that cosine of theta, and this is theta, is 2/5. Well, we know cosine is adjacent over hypotenuse. Well, adjacent to theta would be down here, and they said the adjacent side was 2 over the hypotenuse, which is 5. So we were given that cosine was 2 over 5. So I should know that my secant is 5 over 2. But in order to find sine or tangent, we need to find our missing side here. Because we have a right triangle, we can use Pythagorean theorem to find that missing side. So that's a squared plus b squared equals c squared. Well, we'll say 2 is a plus our unknown side, b squared, equals c squared, which is going to be our 5. So that's going to be 4 plus b squared equals 25. So b squared is equal to 21. But we want b, not b squared, so I'm going to take the square root of both sides. There is no exact square root of 21, and they said they want the exact values. So I'm going to have to leave this as square root of 21 as to not get a decimal that I'm rounding. So sine is opposite. Our opposite of theta is that side we just found, square root of 21, over hypotenuse, which we already knew was 5. My cosecant would be the reciprocal of that, so that should be 5 over square root of 21. But we don't leave radicals in the bottom of a fraction, so I have to do what's called rationalize the denominator. The way you get rid of a square root is by multiplying it by itself, but if I multiply the bottom of the fraction, I got to multiply the top as well. So in the numerator, we've got 5 times square root of 21. We treat radicals just like variables. So this might as well be 5 times x, which would be 5x. So 5 times square root of 21 is just 5 square root of 21. Over square root of 21 times 21, which is just 21. Tangent is opposite, which is square root of 21, over adjacent, which is 2. The opposite reciprocal of that would be 2 over square root of 21, but again, we can't leave that in the denominator, so we have to rationalize. 2 times square root of 21 is 2 square root of 21 over square root of 21 times square root of 21 is just 21. For number 3, this one is a review question of what we talked about yesterday. So it says here our angle is 42 degrees, and we're looking for x, which is the adjacent side, and we're given 18, which is the hypotenuse. So with adjacent and hypotenuse, I know that I am looking to use cosine. So I'm going to have cosine of my angle, 42 degrees, is equal to adjacent, which is x, over hypotenuse, which is 18. And to get 18 out of the denominator, we're going to multiply both sides by 18. So those will divide out. So I'm going to multiply 18 times cosine of 42 in my calculator, and we end up getting that x is 13.4. On the back here, we're going to talk a little bit about angles of elevation and depression. So as it's marked here, an angle of elevation means that you're down below looking upward towards something. So these people in the bubble are looking up here towards the plane. And the angle of elevation exists between their line of sight towards the plane and the line coming straight out from their point of view. So angle of elevation is when I'm looking up at something. While my angle of depression would be like the person in the plane looking downward, down here, towards the people in the bubble. So it's going to be their line of sight along with the straight line coming right out from their line of sight. So that would be this angle here. So angle of depression is when I'm looking down. Okay? These lines up here and here are parallel lines, and your line of sight acts like a transversal. And as we should remember from geometry, whenever we have parallel lines and a transversal, we have all of our different types of angle pairs, like corresponding angles, or same side interior angles, or alternate exterior angles, and so on and so forth. All of those angle pairs are either congruent or supplementary. Well, angles 1 and 2 are on alternate side of the transversals, but inside of our parallel line, so they are alternate interior angles, and alternate interior angles are congruent. What that means is whatever your angle of elevation is, your angle of depression should be the same. So let's keep that in mind as we answer these next questions. These are both word problems, and I just want to remind us that whenever we answer a word problem, our answers should always be in complete sentences. Okay, so the first one says a ship's sonar locates a treasure chest at a 12-degree angle of depression. A diver is lowered 40 meters to the ocean floor. How far to the nearest meter does the diver need to swim along the ocean floor to get to the treasure chest? All right, so here's my ocean waves, all right? And we are in our boat up here. On those ocean waves. Okay, and it says from the boat that they drop a diver 40 meters all the way down to the ocean floor. So our ocean floor is down here, and there is now a diver standing down here, or swimming down here. So from the boat down here to the diver, they said that that was 40 meters to the ocean floor. They also said we had an angle of depression. Remember, an angle of depression means I'm looking down at something. So that would be from the boat looking down. So over here must be where our treasure chest is. And remember, your angle of depression exists between that line that slants downward and the line coming straight out from that place. So here is our line of sight, and I also would look at my straight line coming out from that place. So the angle formed between these two lines is my angle of depression, which they said was 12 degrees. But we know that our angle of depression and our angle of elevation are congruent. So I should also know that this angle measures 12 degrees. What they are looking to find out is how far to the nearest meter would the diver, who's over here, need to swim to get to our treasure chest over here. So I'm looking for the length of this line. Okay, well, if this is my angle, 12 degrees, that's adjacent to that angle, while the 40 is opposite of that angle. Opposite and adjacent tells us we should use tangent. So I'm going to have tangent of my 12-degree angle is equal to opposite, which is 40, over my adjacent side, x. Our first step would be to get rid of the fraction, so I'm going to multiply both sides by x, and now I have x times tangent of 12 degrees equals 40. So now I'm going to need to divide by tangent of 12 to get x by itself. And that is what we would put in our calculator to get that side x is approximately 188 meters, since they did say to round to the nearest meter. The last step would be to write my answer as a complete sentence. So we would say the diver must swim 188 meters to the treasure chest. Okay, our second example says an airplane takes off 200 yards in front of a 20-yard building. So I've got this airplane over here. Okay, and it is 200 yards away from a 20-yard building. So 200 yards to this 20-yard tall building. It then says, what is the angle of elevation the plane must take off in order to avoid crashing into the building? So angles of elevation would mean I'm looking upward. So that would be from the plane up toward the top of the building. So I'm looking to find this angle here. So this is my theta. Well, if that's my theta, 20 would be opposite from it. 200 would be adjacent to it. And if I've got opposite and adjacent, I again want to use tangent. So I'm going to have tangent of theta is equal to opposite over adjacent. And I'm trying to get theta by itself, so I need to get rid of tangent. And remember, to do that, we take the inverse of both sides. All right, so we put that in our calculator, and we're going to get theta to be approximately 5.71 degrees. They didn't specify where to round here. So if they want to know what the angle of elevation would need to be, we would say the plane needs to fly at an angle of elevation of 5.71 degrees to avoid crashing into the building. All right.